here you have learned so many things, and now we are going to learn about the accuracy, the precision of instrument and the errors in measurement. So what do we have to study in this? If I just want to have an observation of any experiment, you would have seen that your teacher suggests you to take a number of observations and number of times. So why do he do so? What is the motive behind this reading or behind taking so many observations? So we will discuss all these things in this lecture. First of all, if I talk about the accuracy, you are having some true value with you. Suppose if I say that my measurement of you can say of this chalk is 3.678 centimeter. Just a crude value I am giving you, this is a true value of this. Now if you are measuring this, and you will be finding what is the true value of this instrument, of this chalk, by using any instrument, you will find that there would be definitely some error. That means your value, your measure value is not up to the true value. So the difference between the true value and the measured value will be your accuracy. In this accuracy, we check how much close a measured value is to the true value. What is the accuracy? It is to measure how much close a measured value is to the true value. I am going to make you explain with the help of example as well, but just a definition this is. Now if I talk about the precision of instrument, what do we mean by the precision? Now you would have learnt a term, that is least count. In the least count, if I talk about a meter scale, you would have seen you can least count of the meter scale is 1 mm. Below that you cannot measure the length of any body. So that means the minimum quantity that can be measured from any measuring instrument, that will be the least count of this instrument. So the precision of instrument is how much resolution the instrument give to us. What do the precision tell us? The resolution. If I talk about the resolution, what do we mean by the resolution? That means again the least value. What do we mean by the resolution? The least value. Okay, so the precision of instrument tell us the resolution of the measured value. Given by the instrument. Given by the instrument. That will be what? That will be the precision of instrument. Now if I talk about the errors in measurement, you would have seen that any measurement cannot be accurate. There is definitely going to be some errors while you are measuring the instrument, while you are doing the procedure, or while if I talk about the least count, the zero errors, there would be definitely the error. So that means there is any uncertainty in measurement, and that uncertainty in the measurement is nothing but the errors in the measurement. What is this? This is the uncertainty in the measurement, or you can say in the measured value. That is nothing but the error. Now if I just start with an example to give an intro of what accuracy, precision and errors in instrument mean to us. Let me start by giving you an example. Just come with me this side. For example, I am having a true value of any measurement, true value of a measured length as 3.678 centimeter. Suppose I am having this much value. Now I am having two instruments with me. One is having precision of one instrument and this is I am having the second instrument. The one instrument measures the value as, the measured value as, okay, so let me just tell you firstly what is the difference between the first and the second instrument. The first instrument is having the precision, or you can say the least count of 0.1 centimeter. Okay. Now if I talk about the second instrument has the least count of 0.01 centimeter. Okay. One is having 0.1 centimeter, one is having 0.01 centimeter. Now if I just use this instrument to find out the measured value using the instrument 1 was, suppose it was 3.5 centimeter, because this is 0.1 centimeter as a least count, so that will be 3.5 centimeter. Now if I see the measured value with the second instrument, that came out to be 3.42 centimeter. Okay. Now what is the difference between these two values? Which is more accurate and which is more precise? Now you will be saying that if I talk about the accuracy, if I will ask you about which value is more accurate, then you will be saying, ma'am, because the true value was 3.678 centimeter. That means if I talk about the 3.5 and 3.42, which is the nearest value? The nearest value is 3.5 centimeter. So that means this instrument is more accurate. This is more accurate and this is less accurate. But if I talk about the precision, which is more precise instrument? Instrument 1 or instrument 2? Now you have seen that the least count over here was 0.1 centimeter and over here the least count was 0.01 centimeter. So you would have seen the significant digits over here are 1, 2 and 3. 3 significant digits, and over here I am having only 2 significant digits. So over here you can see this value is more precise because we have measured the accurate value up to 2 digits, and over here I can measure the accurate value only up to 1 digit. So which instrument would be more precise? Second one. So this instrument is more precise, whereas this would be less precise. So you would be seeing the instrument which can be more accurate but less precise. So this was the difference between the accuracy and precision. Now if I talk about the errors in instrument, there are categorized into 2 different categories, and the 2 categories of error are systematic error and the another one is random errors. Here in the question we says that if the error in the measurement of radius of a sphere is 2%, the error in the radius of a sphere is 2%, then what is the error in the determination of volume of the sphere? Now here sphere has been given, the volume has been given, the radius has been given. So definitely we are going to use one formula, that is nothing but V equals to 4 by 3 pi r cube. This is nothing but the volume of sphere. Now since we know that we have formula V equals to 4 by 3 pi r cube, which is giving a relation between the volume and the radius. So let us just see what are they asking? Error in the radius of the sphere has been given as 2%. Now you know that we have covered the topic how to find out the error. So simply if we are going to find out the error, we are going to write this as delta V by V. 4 by 3 pi is constant, so we are going to ignore this term, and this r is having the power of 3. So this 3 will be coming here and we will be having delta r by r into 100%. This is the percentage error which has been given over here. This is 2% has been given. So now what we are going to do, we have been given this value of delta r by r. In the question, the value that has been given to us into 100% equals to 2%. This has been given to us. So what we are going to do, we are going to put the value over here. We will be having 6% as the volume error. Delta V by V, or you can write it as delta V by V into 100 equals to 6%, and that is what we are having the error in the determination of volume of the sphere. So the answer is 6%. Okay. So this was the way to handle such question. Now we will be moving towards the next question, that is the question number 2. Okay, so here the question arises from the unit dimension. Here the velocity v of a particle at time t is given by v equals to at plus b upon t plus c. This equation has been given where a, b and c are constants, and we have to find the dimension of a, b and c. Have I told you how to find out the dimension of such things, of such equation? Yeah, I remember I telling you, how to find out the dimension of the equations, of the formulas and so many things. So that is the way how we are going to start the question and we are going to proceed further for it. Here in this question we have been given v equals to at plus b upon t plus c, and we have to find out the dimension for a, b and c. So how we are going to do this? Just look at this. I have told you one principle, that was principle of homogeneity, and this principle says that whatever the values has been written over here in the left hand side and the right hand side of the equation, they are going to have the same dimension. That means the power of the dimension should be same on both the sides of equation. So we are using this principle. In that, according to that principle, we can say that v equals to at. V equals to at, that means I am talking about the dimension of v equals to at. So dimension of v is velocity. So dimension of velocity is what? We have learnt about that. It is Lt minus 1 equals to a into t. A is written as such. Now t is time. So what could be the expected dimension of a from here? Lt minus 1 divided by t. So finally we will be having the dimension of a as Lt minus 2. This is the dimension of a. What we have found? We have found the dimension of a as Lt minus 2. Now b and c are left. Now accordingly, similarly with the same principle, we can say t and c, they should be having the same dimension because they are being added up, and when the two things are being added, that means their dimensions are going to be same. So we can say c, the dimension of c equals to the dimension of t. How we are going to write the dimension of t? This t is nothing but the time. So we can say this is nothing but capital T, because we denote the dimension of time as the capital T with the square brackets. So, the dimension of C has been found out as the capital T. So, I can write over here, this is capital T. Now, one thing that has been left here is B. So, let us just proceed and find out the dimension of B. Now, here in this equation we can see that again this complete B upon T plus C should be equals to V, because principle of homogeneity. So, let us just start. We can write that B upon T plus C equals to V. Now, again we know that the dimension of T and C is equal. So, we can say, and B is what? B we have to find. So, we can write it as V into T plus C. This should be the dimension of V, this should be the dimension of T plus C. So, we know that the dimension of V, that means velocity, is LT minus 1. Now, multiply it with T plus C. Now, as I told you, this C and T are equal, they are having same dimension. So, you can write it as 2 times T, 2 times of capital T. But we ignore the numerical values over here when we are dealing with the dimensions. So, we can simply write this as capital T. So, we are now having T minus 1 plus 1, they will be cancelled. So, we are having the power of T as 0. So, finally, we can write the dimension of B as this, L. So, finally, dimension of A, LT minus 2, dimension of B, L, dimension of C is T. This was the question. Now, we will be moving towards the next question. The question number C says that in a vernier caliper. Now, by reading only the mere vernier caliper, I can understand the question could be related to the least count. So, yeah, I can see the least count as well. This is the least count. First of all, read out the question. In a vernier calipers, n divisions of vernier scale coincide with the n minus 1 scale, n minus 1 divisions of the main scale, in which length of one division is 1 mm. So, find out the least count of the instrument. I remember I told you how to find out the least count of vernier caliper as well as screw gauge. So, the question is related to vernier caliper, and the situation has been given over here that n divisions of vernier scale, n divisions of vernier scale coincide, that means we are going to write an equation form, with the n minus 1 division of main scale. Okay. So, we can simply write this again in the form 1 vernier scale equals to, n vernier scale division equals to n minus 1 main scale division. So, if I talk about the 1 vernier scale division, I can simply write it as n minus 1 upon n main scale division. Now, because they are saying to find out the least count of the instrument, we know least count of the vernier caliper is nothing but 1 MSD, that means 1 main scale division, minus 1 VSD, that means vernier scale division. So, we are having the value of 1 vernier scale division with us, that is n minus 1 upon n. So, we are going to put the value n minus 1 upon n main scale division. So, let us just solve for this n minus n plus 1 divided by n. So, we will be left with nothing but, let me just write over here, we will be left with 1 upon n multiplied 1 main scale division. Now, here we know that in the question we have been given that 1 main scale division, the least value is nothing but the 1 mm. So that means one main scale division is 1 mm. So going to put the value multiplied by 1 mm. You can also convert this into centimeter. If we want the answer to be find out in the terms of millimeter, so we will be having 1 by n. If we want to find out the answer in the range of centimeter, so you can write this as 0.1 centimeter by n, or further we can write it as 1 upon 10 n centimeter as our least count. Alright, this is the way how can we find out the least count of the vernier caliper. That is why I have given one complete lecture based on the vernier caliper, how to deal with that, all the kinds of error in the vernier calipers and all the kinds of error in the screw gauge. So go through that lectures and understand that these kind of question can be arised from that topic.